Hello students, in this video we are going to talk about exception handling. So an exception, you can think of an exception to be something like an error. However, not all errors are exceptions. Okay, so when you write a program and you get a syntax error, this is not an exception. On the other hand, if you are trying to read a file in your program and then that file does not exist, then your program will terminate abruptly. So in that case, that is say a file is not found, then what you have is an exception. So you have the concept of error and you have the concept of exception. All errors are not exceptions. Some errors are exceptions. So in short, you can say that an exception is something where your program behaves in a way it is not supposed to behave. Okay, and you have things like you cannot, when you run the program again, okay, and if you don't change anything, then that exception will occur once again. So whenever we write a program and we can anticipate that when we are trying to open a file, the file may not be there. So when we can anticipate that this kind of problems might occur, then what we can do is we can prevent the program from stopping abruptly if that issue occurs, and then we want to make it exit in a graceful manner. We would like to give some message and then exit. Because the program has to exit, there is no other option. You are trying to read a file which is not existing. It cannot go ahead, the program cannot go ahead. So in such a way, in such a situation, you can have an exception handling. You can include exception handling in your program, and this will ensure that you don't your program exits in a graceful manner. So exception handling can be defined as a structured manner in which we can handle exceptional situations in our program, okay, and make our program exit gracefully or come out gracefully from such scenarios. And in Java, it provides a way of handling these exceptions, and we have a class called the exception class. We have a class called the exception class. This is a built-in class, and this class is responsible for handling, or not for handling, but for representing any type of exception that can occur in your system. So we will look into the class hierarchy. So this is one of the classes. Then for a number of known exceptions, which we know that these type of exceptions can occur, like file not found or array index out of bound. You want to access an array element, but it is a 10-element array and you are trying to access the 11th element. In such a situation, there will be an exception, and then there is already a built-in class to take care of that, to represent that particular exception. So in your program, by default, there is no exception handling. So when you write a program and you try to access an element of an array which is out of bound, your program will terminate, giving an error message. Okay, so we will have to incorporate error handling or exception handling in our programs. And to do that, like I said, it's in a structured manner. So there are constructs in Java which helps us in implementing this exception handling. So structured exception handling in Java consists of 3 blocks. The first is the try block. Okay, this is the syntax, try in small letters. So try block, this is in our program, we can anticipate that this is where when I am opening a file, I can anticipate that the file may not be existing. So that particular code where I can assume that an exception can occur, I'll put it inside a try block. Okay, so in one program, you can have the try block where you put all statements which can lead to an exception. So when you put the code where exception can occur inside the try block, then you are actually implementing exception handling. So if I have some other code somewhere above or somewhere below the try block, okay, those statements, if they lead to some exception, then that will not be handled by your program. Only the statements that appear inside the try block, inside this opening parenthesis and opening curly braces and closing curly braces. Then you have the next block, that is catch block. So in a catch block, what you have, you can see the catch block, the keyword catch is used, then exception class and the exception object. So as I have mentioned that Java provides a number of classes to represent different type of exceptions, then the catch block is like, you can think of this, if you think of this whole thing as like a switch case, then this is like your case. This is your switch. So if this exception occurs, or if exception belonging to this class occurs, then it will be the code that is here within the catch block gets executed. So we can give multiple, you can have multiple catch blocks in your program. So if you think that you can have in your program, in the statements that are there in this try block, you can have 3 types of exceptions. Say exception type A, type B and type C. So you can have 3 different catch blocks in the same program. So if it is the first type, then it will be caught in the first block. If it is the second type, then it will be caught in the second catch block. If it is the third, if it matches the third, then it will execute the code that is given inside the catch block. So whenever any exception occurs here in some statement that is there inside the try block, okay, the exception object that you have, that will be, we say that an exception is thrown. So it throws an exception. So when that exception is thrown, okay, it will be caught by one of the matching catch blocks. So if it is throwing an exception object of type A, exception A, then the matching catch block for A will catch it. And by catching, what do we mean? We mean that the code that is within that catch block will get executed. Now if I have 3 catch blocks, I'll just take an example later and show you. So this is what happens in the catch block. So what you have here, you give the exception class here to which exception you want to catch, and then you just give an object name here, variable name. So this becomes an object of this class, okay, and the exception object which was thrown is caught by the object that you specify out here, okay. So the exception object is thrown in the try block and it is caught in the matching catch block, and then here in the catch block you can put code which will be executed if that exception occurs. So here you can put some message, some kind of a error message or something, and then you can exit from the program. Then comes the finally block, okay. So the finally block, here you can have code. This comes after all the catch blocks. So here you can put code which will be executed, okay, after the exception has been caught. So whether there has been an exception or not doesn't matter. If there is an exception, then it will go to the catch block and then it will come to the finally. If there is no exception, then code in try block will get executed, then it will come to the finally block. So the code here will be executed irrespective of whether there has been an exception or not. So code that will always execute. So that is the finally block. and this finally block is optional. So you may not put a finally block. But remember, if you are putting a try block, you have to have at least one catch block. Okay? And if you have a catch block, you must have a try block. Okay? So these are the three different blocks that you would need in structured exception handling in Java. So let us see an example. So this is a part of a program. So here I have a class which is called exception test. Inside this I have a main function. Now in the main function, you can see this is the main. Here I have a string s which I have initialized to welcome. Okay. Remember, this statement is coming outside of any try block. Then this is the try block. So from here to here I have the try block. So in this try block, you can see that I have put what? I have put a statement here, s is assigned null. So the reference of s to the string welcome, I have removed it. So s is now pointing to nothing. This string object s is now pointing to nothing. So no memory allocated, nothing. And then here what we are trying to do, we are printing the value of s dot length, the length of the string. Now s is not assigned any memory. So when we try to access s dot length, it cannot give you any answer. So in that case, it throws an exception which is known as the null pointer exception. So this throws a null pointer exception. This is where the exception occurs. So exception occurs. Now if these two statements were not there inside the try block, inside the try block, then when this exception occurs, the program will stop and an error message, system generated error message will be displayed. Okay, which is usually very cryptic. So now since we are implementing exception handling, so we have to have a catch block corresponding to this exception. So here I have one catch block here, catch null pointer exception. Now from where did I get the name of this class? For this you have to look up the hierarchy of the exception class. You have to look up the hierarchy of this. So the null pointer exception class, this belongs to the exception hierarchy of classes. We will see that in the next video. So here E is the exception object. Okay, so the exception occurs here. This object is thrown and it is caught by this catch block. Why? Because it matches. Okay, this is the exception which is occurred. So null pointer exception. So it matches here. So it will be caught in this catch block. Now I may have some other catch blocks also here. Suppose I have a array index out of bound. So I may have another catch block, array index out of bound. And E can I give? Then I may have some code out here. So it tries to match. So here it tries to match. Is it a null pointer exception which is occurred? If yes, then it will come inside this block. If no, then it will go and check in the next catch block. So it does not match this one, so it will not come here. Once it finds a match, it will not go to the next. Okay, just like again in a switch case. So here since it finds a match, it will be caught by this exception object E. So E now will represent the exception which has occurred. So what are we doing inside the catch block? We are printing system.out.println null pointer exception has occurred. Okay, and E.toString. Now E is an object of null pointer exception class, and toString will have some details about this exception object. So toString is going to convert it to string and print the details. So this is the error message which will be displayed. Null pointer exception has occurred, and then the details about the exception. And after this, it will not go to any other catch block, nor to any other instructions or any other statements in the program. It will go to the finally block. So if I have a finally block, here, then that code for that finally block will be executed and the program will terminate. Now suppose here, instead of this exception which has occurred, let's say some other exception has occurred. Okay, some say null pointed exception, array index out of bound has occurred. So what will happen? The moment the exception is thrown, it will come to the first catch block, match. Is it matching? No. Go to the next one. Is it matching? So here it finds a match, so it will execute what is there in catch and then go to finally. And if it does not match any, suppose it is neither a null pointed exception nor a array index bound exception, which is some other kind of exception which has occurred because of the statements in the try block. So in that case, it will behave as if there is no catch block. There is no matching catch block, so as if there is no exception handling. If there is no matching catch block, means there is no exception handling. So after writing so many things, you don't want that if you have not foreseen that this type of exception can occur, you don't want that the whole system will collapse because of that. So we give one catch block which can catch all types of exception. Okay, and that is the class is the exception class. So I'll write it here. Exception. And you have to note out here. So the exception class is like at the top of the superclass, at the top of the hierarchy. So if it is neither a null pointed exception nor an array index bound exception, it is bound to be a exception. It will always be an exception. Okay. So in that case, the code that is there inside exception will execute. Okay. So if I write down like this, if you just look at the flow. So I have inside my try block, I have some statements. I am anticipating that exception A can occur, exception B can occur. Okay, and then I have put exception, and then I put finally. So, if no exception occurs, then the statements here will execute and control will come to finally. Okay? If an exception occurs, say if exception A occurs, then the control comes to this block, it will execute this and then come to finally. If exception B occurs here, then the control comes to this, okay, without executing these part, it will execute this and then it will go to finally. If exception C occurs, now I don't have a matching catch block for C, so if exception C occurs, then it will go to this block, okay, the exception, because C is also an exception. A subclass is also a superclass object. So it matches this, it will execute whatever is here and then come to finally. Now if I have not put this part, the exception one here, then if exception C occurs, then it matches neither of the two catch blocks. So what it will do? It will just terminate abruptly. So we don't want that to happen. So C here is a uncaught exception. Uncaught exception in this case. Now we don't want to leave an uncaught exception. So what we will do is we will put a general class, that is the exception catch block with exception object for the exception class, which will catch all other uncaught exceptions. Now if instead of putting a try block, you would prefer that all the statements inside a particular method are included in the exception handling routine. In that case, you can write something like this. So this is a method, public int some method. Now here we have added a keyword called throws. Okay, so the throws keyword is used to indicate that this particular method may throw this type of exception. The statements inside this method may cause the exceptions which come out here. So we have listed throws, and then here it says null pointer exception. So the null pointer exception, so if there is any statement, any code here which can cause the null pointer exception, then it will be caught in the corresponding catch block. So the throws keyword can also be used. In that case, all statements are included. If you have multiple, if you want that this particular method may have multiple, may throw multiple exceptions, then just put a comma and write the next one. So it can be comma separated.